Is this the first quiz we've had since the last test?
Yeah, sure.
Right?
Yeah.
Okay.
Yeah.
So then this becomes part 1 of our test 6 review packet, right? Okay. So this is the first material on test 6, which this is good, new, different stuff. So this will be nice. Okay. First, convert z to polar form. So we start with the modulus of z, which is going to be the square root of 1 squared plus radical 3 squared. 1 plus 3 is 4, and the square root of 4 is 2. Then the argument of z is going to be the inverse tangent of radical 3 over 1, which is 60 degrees, or pi thirds radians. So z is 2 cosine 60 degrees, or pi thirds radians, plus I sine 60 degrees. So that's the answer to part 1, yeah? Number 2, convert k to rectangular form. So we've got this radical 2. Cosine 5 pi fourths is negative radical 2 over 2. Sine 5 pi fourths is also negative radical 2 over 2. When you distribute a radical 2 in there, radical 2 times radical 2 is 2. So you get a negative 2 over 2 minus 2 over 2i. So your answer should have been 1 minus I. Agreed. Find k times q. Since both k and q are in polar form already, we're going to multiply the modulus. So radical 2 times 3, we just call that 3 radical 2. And then we add the argument. 5 pi fourths is what? 225? So 225 plus 120 is 345. So you can just write cosine 345 degrees plus I sine 345 degrees. Number 4, evaluate q to the third. I was amazed at how many of you are horrible at raising 3 to the third power. It is not the same as 3 times 3, right? I would say it might be near a majority of people who put 9, which was mind-boggling. But so we want to raise 3 cosine 120 plus I sine 120, and we want to raise that to the third power. So it's going to be 3 to the third cosine of 3 times 120. We want to multiply. What is 3 times 120? 360, which is a positive real number. So your final answer is just the positive real number 27. If you wrote 27 cosine 360 plus I sine 360, I gave you full credit. I kind of laughed at you a little, but I allowed it. Okay? Make sense? Just.
So our test is 22nd, right?
Is that the plan? Is that the schedule? Yes.
What if we don't have classes?
Why?
Because they're taking each class as senior, junior, and freshman, sophomore, taking each of them out for 2 days for the second presentation.
Really? On the 22nd?
Right after
That's stupid.
All of your test days.
I'll find that out and maybe move it to the 21st. Yeah. No. Okay. Number 5. Find all fourth roots of the number 1. A lot of you probably viewed that as, if I find both square roots of the number 1, which are what? 1 and negative 1, I can then find both square roots of those numbers, right? Won't all of your fourth roots be the square roots of your square roots? So you could say, all right, the square roots of the number 1 are 1 and negative 1. And then the square roots of 1 are 1 and negative 1. And the square roots of negative 1 are I and negative I. And that's it. Those are 4. Okay? Though I kind of, even though there are other methods, I expected to see everybody use a polar method. So the first thing you want to do is take the number 1, convert it to polar form. That's going to be 1 cosine 0 plus I sine 0, yeah? Right? Visualizing where that number is in the complex plane tells you immediately it has an angle of 0 degrees. Then we want to fourth root that. Principal root. So I'm going to use a radical here. Well, the principal root of 1 is 1. And 0 divided by 4 is 0. So here's your first root. That's the number 1. Then I want to add 90, right? Because if there are 4 roots, we add 90 each time. So we're going to have cosine 90 plus I sine 90. Cosine 180 plus I, and that, by the way, is I. Cosine 180 plus I sine 180. And that's negative 1. Cosine 270 plus I sine 270. And that is negative I. And then cosine 360 plus I sine 360, which is just a repeat of 1. So there are your 4 fourth roots of the number 1. Agreed?
Yes.
Okay, number 6. Find all 3 cube roots of the number negative 27. The modulus of negative 27 is what? 27, not negative 27. It is positive 27. And the argument is 180, not 0. However, if you wrote negative 27, cosine 0 plus I sine 0, that would work. A lot of people who wrote that made mistakes, though. So just be careful. So we want to find the principal cube root of this. So we do the principal cube root of 27, 180 divided by 3. So your first root is 3, right? Because the cube root of 27 is 3. And make sure you're writing cube roots. A lot of people are writing like radical square roots from that point on in the work, and it just didn't make sense. 180 divided by 3 is 60, so you're going to have 3 cosine 60 plus I sine 60, of which we can write that in exact form, because it's on the unit circle. So I'm going to write that as, what is 60? 1/2 plus radical 3 over 2?
Yeah.
So when you distribute the 3, that's 3 halves plus 3 radical 3 over 2i. So there's one of your roots. And then I add 120. 3 cosine 180 plus I sine 180. That's the number negative 3. And then 3 cosine 300 plus I sine 300. And that is positive 3 halves minus 3 radical 3 over 2i. A lot of people had the signs backwards. They had negative 3 halves plus 3 radical 3 over 2 and negative 3 halves minus 3 radical 3 over 2. And so somehow we got the opposites of the roots. Yes?
I heard you. Okay, how could you have used 0 degrees? Like, that doesn't make sense.
If you call the modulus a negative number.
Okay.
So let's say, go in the direction of 0 degrees, but go negative 27, which means go backwards. So aim that way, but go backwards.
And that could be the same answer.
It works. It's not the definition of modulus argument. Modulus has to be positive, but it works. Okay, because the principal cube root of negative 27 is negative 3. So you had negative 3's here, but you had 0, 120, and 240 here, and it worked. Okay? Now, remember how I said I didn't know how the calculator was doing cube roots, and I think I figured it out? They were using the actual modulus argument. This problem right here proves me wrong. Right? Because the actual modulus argument form of negative 27 is 27 cosine 180 plus I sine 180. So therefore, when you cube root the modulus and divide the argument by 3, what's the first root you get? This one. But if you type negative 27 raised to the 1/3 power in your calculator, it gives you this one. So I modify my definition to say, if a root is real, it gives you that one. If a root is not real, it gives you the one you get from the modulus in the argument.
So perhaps it just gives you the real roots.
Yeah, but sometimes numbers don't have real roots, like number 7 in your quiz. Right?
Yeah.
So this is a perfect example. This problem doesn't have a real root. Oh, where is it? It disappeared. Somebody read it to me. We're finding the...
2 minus I.
Okay, so let's find the 3 third roots of 2 minus I. First of all, the modulus of 2 minus I, that is the square root of 4 plus 1. So that is a square root 5. Okay? The argument of 2 minus I, that is the inverse tangent of negative 1 over 2. That is a negative 26.565. I'm going to store that in my calculator for A. Negative 26.565 degrees. So, my principal cube root of 2 minus I, that's going to be the principal cube root of the modulus. So you're going to have the cube root of the square root of 5 times the cosine of negative 26.565 degrees divided by 3 plus I sine negative 26.565 degrees divided by 3. So if we type this in our calculators, that ends up being 5 raised to the 1/6 power cosine A divided by 3. Now, I have my graphing calculator, so I'm going to cheat, which you couldn't do. You had to do this in 2 separate steps, right? We get 1.292 minus 0.201 I. Agreed? So there's 1. Box that in. Next, I want to add what to this angle? 120, because there's 3 roots. So my next root is going to be the cube root of the square root of 5 cosine of, we'll say negative 26.565 degrees over 3 plus 120. I don't really feel like calculating what that is, because I don't really care. It's a 111 something, yeah? Right? So my calculator, I'm going to say 5 raised to the 1/6, because that's what a cube root of a square root of 5 is. Parentheses. Cosine A divided by 3 plus 120, and you could have typed it in your calculator just like that. Plus I sine A divided by 3 plus 120. And we get negative 0.472. It was amazing how many people had major rounding error. You got a calculator that can store, do it. And the next one is 1.220. Saw a lot of 1.219s. That to me is not rounding error. That's just you're not good at rounding. Okay? And then the final one is cube root of the square root of 5 cosine negative 26.565 degrees divided by 3 plus 240. Which comes out to what? 231 point blah 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 blah. Blah 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 blah. So then I'm just going to hit second enter. Change these to 240. Somebody just snore?
No, I wasn't snoring.
So negative 0.820 minus 1.018 I. All of those numbers, if you multiply them times themselves 3 times, you get 2 minus I. Good?
Yes.